Imagine you're the boss of a world-famous toy store, and your claim to fame is selling giant, extremely fluffy teddy bears. To keep things simple, you have one very strict shipping rule. Every single toy you sell gets packed into a massive cardboard box for delivery. Because you only ship large items, unchanging job to do, a single highly tuned machine is the best tool for the job. Then your store gets a little too popular. Kids start ordering tiny 2-inch action figures alongside those massive bears. Automatically putting a tiny little plastic figure into a giant, expensive shipping box wastes cardboard and takes up way too much space on the delivery truck. When you force one big machine to handle both, you tangle the instructions and slap on messy new gears for envelopes. The machine completely jams, breaking down because it cannot fold a giant box and seal a tiny envelope simultaneously. This is a common trap in the digital world. It happens when different, conflicting tasks are crammed into one single place, making the whole system too rigid to change. To fix the jam and clear the floor, you need a new strategy: the factory method. Instead of relying on one massive, overworked machine to do everything, you hire a shipping manager to act as the central brain. This manager has a very limited job. They just look at the size of the order and press a general "Pack It" button. They don't do any of the actual packing themselves. That button routes the order away from the manager and sends it to separate, specialized mini-factories. The box factory only ever handles boxing up the giant teddy bears, while the envelope factory only focuses on slipping action figures into paper mailers. By separating the decision-making from the actual building, the system never gets confused or jammed, no matter what toy the customer orders. If the manager never actually sees the packing happen, how can they be sure the mini-factories will finish the job correctly? They rely on a strict golden rule that every mini-factory must follow to even be allowed on the factory floor. As this diagram shows, whether it's a box or an envelope, it must come out with a standard shipping label attached. As long as that uniform label is there, the manager is happy. They don't need to know the secret internal steps used. This rule creates a bond of trust. The central system knows that as long as a worker follows the standard, the final result will always fit the rest of the process. Years later, your toy store introduces a highly valuable new product: super rare, shiny toy crowns. These crowns are too fragile for envelopes and too expensive for standard boxes. They need a brand new, highly secure option: the insured box. With the old single machine setup, you would have to shut down the entire warehouse and rebuild the main machine just to add a high-security safe. With the new setup, you simply plug in a separate safe factory. The manager gets a secure pack button, routing orders there. The original system keeps running without a hiccup, shipping bears and figures, while the new crown option is added alongside them. This setup gives you the freedom to grow. You can add 100 new shipping methods without ever having to touch or risk breaking the parts that already work. The factory method takes a giant, messy list of instructions and turns it into a clean team of specialized, independent workers. This is how your favorite video games manage their worlds. When the game calls for a creature to appear, it doesn't look at one giant manual. It just sends a request to a specialized monster maker that builds the dragon or the goblin right on the spot. Clever coding is about organizing your instructions so clearly that your world always has plenty of room to grow.